All right, so let me clean up some of these. Let's go to networking. We'll start with port scanning, where you just send SYN packets to a server to see whether the server is listening or not. So we'll start with this one called grab.py. All right. So this we've done before, where we just use the socket. You import the socket library, you create a socket object, and then you use the connect method of the socket instance that you have created, and now you can connect to a server on a port. And by the way, there really are two open parentheses and two closed parentheses, and that is because the person who wrote this library method chose to use one object, which is a tuple containing two quantities, instead of using two parameters. So anyway, that's how you do it. The first parameter is the URL, and the second parameter is the port number. So this is going to connect to one of my servers, AD, on port 22. And all right. And so then you print whatever comes back from it, and then close. So this will just make a connection on port 22. So if I run Python 3 on grab.py, oops, got to spell it better. All right. So it connects to my server. Now port 22 is SSH, and the specification for SSH says when you get a connection, you must return a banner telling it what version of SSH you're using. And my server is just a default Ubuntu server, and it's obeying the rules. So it replies with a header giving you the version of SSH. So that's fine. All right. Now let's try an error. So if I modify that program, I think it's just up here. Yeah. And so if I change that to like ADX, which is a server that does not exist, and run it again, now I get a big ugly error message. This is what happens when you don't handle errors in Python. It tells you what line the error occurred in. It even shows you that line of code, which is kind of useful. And then it has this kind of error, node name nor server name provided or not known. So what it means is it was not able to find this object in DNS, which is true. So it's not very pretty if you don't handle errors very well, but it did connect and fail for that reason. So we can make an improved grab. This is what real programmers do, which I'm totally not, by the way. In case you think you're going to learn good Python, you're not going to learn good Python from me. I only know how to write sloppy, plain Python. There's all sorts of stylistic improvements that I don't know. I write Python the way I wrote Fortran in the 1970s. So you can do that. It's not considered a best practice, but you can get some things done this way. If you want to really learn Python the right way, then you can go far beyond what we're doing here. This is sort of cheap hacking Python for people who don't know it at all. Anyway, so now this is, if you're going to do things more professionally, you handle the errors instead of letting your program just crash and put out a default ugly error. So if you want to handle an error, before you do something that might fail, you try, : Then you have a block of indented code, which is what it's going to try. And if any of that fails, it will go to the except. And then you can pick up the error from the socket object as error and print it out. So that's all it does. It's instead of just crashing with default, it's going to try to do this, connect and receive something and close. And if any of those things don't work, it'll go down here. So it's going to be a little prettier. So if I run that one, Python 3 grab 3, then it doesn't print out this stuff. It just prints out the error name, which is a little bit friendlier. Guess it prints the error number 2. All right, and that's something you can do if you want to do error handling, which can turn out to be handy in some of the more difficult challenges. So let's take a look at grab 4. All right, and I'm going to take this out. It wasn't there at first. Okay, so this is what happens if I take the exact code we had before and I just change the port number to 80, which is HTTP. Now my server is listening on port 80. It is a web server. So if I run that one, it's just waiting and waiting and waiting. The problem is it sent a SYN, it got a SYN ACK, it sent an ACK, It made the connection, and now my program is waiting for the banner. And HTTP does not have a banner, especially because HTTP is not intended to be used this way with interactive commands. HTTP is supposed to be used by a web browser that sends a structured HTTP request. So my server is waiting for a request, and my client is waiting for a banner. And this could go on for a really long time, like 2 minutes, waiting. It's stuck at this point. So that's no fun. I cancel it with Control-C. And what I have to do is add that line, set timeout. So I've created this object. I can do s.setTimeout, and I can set it to some small number, like 1 will do. All right, now it'll only wait 1 second before giving up. So 1 there. Now it doesn't make me wait forever to find out that the port is open, but it's not sending me a banner. All right, so that's good if I want to do a port scan where I'm going to try a lot of ports and get different options. So we can try this one. If you want to make it interactive, grab 5. This one here starts with the same stuff, including the timeout, and now I use the input command. Input will print this string out and then take data from the user. It'll interpret it, however, as a string. So if you want it to be a number, you have to use the integer method to turn it into an integer. So now I have a port object that's an integer. Now I'll connect to that server on that port number and see what happens. And I didn't bother to do the error handling, so it'll give me an ugly result if it fails, but at least it isn't going to make me wait forever, and I can adjust the port. So if I run that one, Python on grab 5, I can now connect to port 22 and see that banner. And I can connect to port 80 and get a timeout. And if I try to go to port, say, 79, then I get connection refused. And those are the 3 possible options. This is a closed port where the server is not listening, so it responds with a reset. This is the one that is listening but doesn't have a banner. And this is the one that's listening and has a banner. So you can now handle all those options. Although since I didn't handle the errors, the program will always stop when it hits an error, and if I was trying to scan through a whole range of ports, I would have to actually handle the errors to get the program run on to the next one. So now you can make a port scanner. You can do port 1 by 1 just by using grab 5, and you can make loops and handle the errors if you want to do more. And so there's one service right here with a port ending in 000 you can find. And there's another one on a server with a port somewhere in this range of 30 ports. So you got to scan through 30 of them. And here's one which will make sure you can automate the whole thing. So when you connect first on port 22010, it will tell you to connect to this other port, and you have 3 seconds. So you have to connect to this in Python, collect the string, parse the string to find the next port number, and make the next connection before the time runs out. And here's another port forwarding down here where you now have a whole couple of paragraphs with several numbers in it, but only one of them is going to be a valid 5-digit number, giving you the real port number to go to next. So you'll have to do a bit more parsing of this string to find the good port. And again, you don't have much time to do it, so you can't reasonably just do it by hand. So that gives you a little bit of practice handling some network traffic for simple TCP networking.